Hey guys, so today I'm gonna start a new chapter. This is chapter 10 in the textbook, but this is topic number 9. Okay, so there is one chapter is we are not gonna teach it. We are not gonna teach it. So here this is chapter 10, but actually this should be in the textbook should be chapter 9 here or topic number 9. Okay. So before I start, I want to clarify uh, how this chapter is different from what we did before. Okay, how it is different. First of all, you should understand we have something we call DC sources, and also we have AC sources. Okay. AC. So DC sources here can be current or voltage. DC means direct current sources, current or voltage. Okay. In DC sources, actually the voltage of the current is constant, okay, over the time. And that's what we have done so far. So all the circuits we have done so far in this semester, all the sources were DC sources. Okay. We have other sources, we call them AC sources, alternating current sources. So these sources, either current or voltage, you can see the voltage are sinusoidal, okay? So cosine or sine, they change over the time, but we mainly were interested in sinusoidal, sine or cosine, simply because all communication, even the power we have here, all of them are sinusoidal. That's why we are going to limit our study or our work to sinusoidal. So this is the main difference. So in this chapter, we didn't do that before. We're going to see a circuit, and this circuit can have the elements we used before, like resistor, like inductors, like capacitor, even op amps. Okay, but the main difference is the input here is going to be AC. Is that okay? AC. So this chapter, we will learn in this chapter, if we have a circuit like this one, and the input is AC, how can we analyze AC circuits? Again, analyze means we need to find the current, we need to find the voltage everywhere, okay? As I told you before, but you need to be careful here. If the input is DC, you remember? So in DC, in steady state, inductors becomes like a short circuit, and a capacitor becomes open circuit. This is if it is DC. But in AC, no, it is not. It's not going to be open, short and open. So it's going to have a current. It's going to have a voltage. Okay. So this is a big difference between AC and DC. One more thing here. If the source here, for example, Vm cosine omega t plus theta, okay? If this is a source here, this source, as I'm going to explain details, it has an amplitude here or maximum value. It has omega t as we see here. Omega here is actually 2 by f, which is the frequency. Also, it has theta. Theta is the phase or angle, the angle phase. I will explain it. But what I want to say here is, if this is the input, if the input is something like that, cosine, something like that, so for sure, if you get the voltage or the current anywhere, the voltage or the current should have the same frequency. So omega will be the same everywhere. Here, omega, okay? These circuits, we call them linear circuits. Linear circuits, we don't change the frequency. So the frequency omega here will be the same everywhere. But what may change is amplitude may change, or the phase also may change. But the frequency will be the same everywhere because this linear circuits. Anyway, I will give you details on this part here. The good news is no new theorems. I'm not going to teach any new circuits. You got what I'm saying? So that means for these circuits, we are going to use all the theorem we did before in DC circuit. So we are going to use Kirchhoff current law, Kirchhoff voltage law, Ohm's law, mesh and voltage node analysis, current division, voltage division, Norton's, Tiffany. So everything we did before in DC circuit, we're gonna do everything in DC circuit. That's good news, right? I'm not gonna teach any new theorem for circuits, okay? This is a good news. But the bad news is, here, what's gonna happen here, if this is exactly what we will do this chapter, okay? We have a circuit here in time domain. So in order to analyze the circuit, I will teach you how can we convert this circuit into what we call a complex domain. Complex domain means everything here is going to be represented by complex numbers. Voltage, current, resistance, everything. So here that's exactly That's exactly what we do. Number one, if you have a circuit in time domain, you have to convert this circuit to another circuit in complex domain, where everything is represented by complex numbers. That's number one. Okay. Number two, you have to do all calculation using the theorem we did before. You have to do all calculations using complex numbers. Okay. This is the only difficulty we have in this chapter. The only difficulty in this chapter is everything will be done using complex numbers. That's it. So if you know how to do computation using complex number, everything will be similar to what we did before. Nothing is new. Okay. So and then after you calculate the current, you calculate the voltage, you calculate the resistance, you calculate everything. The result you will get here. So for example, I want to calculate the current. You will get the current complex number, or you are going to calculate the voltage complex number. Now you need to convert the result you will get to the time domain again. Okay, guys? So that's exactly what we do. Number one, if you have a circuit in time domain, you have to convert it to complex domain, okay? Where everything is represented using complex numbers, number one. Number two, you have to use all the theorem we used before to do the calculation. You are going to get the result. Result here means voltage, current. You are going to get everything, but in complex numbers. Now you need to return it back, the result you got here to time domain. For sure, I will teach how can we do all of that. But some can ask me, so why have to convert to complex domain, do some computation for complex domain? Why I don't only just simply work on the time domain? Okay, simply because it will be more difficult, the calculation. I have one example just to show you how it will be difficult to do the computation in the time domain. Okay, that's why it's easier to do it this way, to move it, to transfer it to complex domain and then do the calculation and then convert the results you get to the time domain. Any questions, guys? This is a big picture. That's what we'll do in this shop. Number one, let me summarize what it says. Number one, I'm not going to teach a new theorem. We're gonna use everything we used before from Norton, Thevenin, voltage division, current division, everything I told before. We will use it. It's the same like DC circuit, but we will use it in complex domain, and then you need to convert it. I will teach how can you convert the circuit from time domain to complex domain. I will teach after that how can you use the theorem here in complex domain, and then once you get the result in complex domain, you have to convert it back to time domain. I will teach all of that. Is that okay? But before I start that, I will make a revision, very quick revision on complex numbers. Okay? How can you add complex numbers? What are the complex numbers and so on? Okay? But again, the only difficulty here in this chapter is just because everything will be done in using complex numbers. Okay? So as you know, in complex number we have an operator. This complex operator, which is J. J is actually the square root of -1. Okay, you know that. You know G to the power 0 is 1, G to the power 1 is I think that's a mistake. I will correct it. G to the power 1 is J, so please correct it. I will correct it. G to the power 1 is J. G square is actually square root of -1 square, which is -1, and so on. Okay. So, and if you come to G to the power 4, it actually becomes 1. Okay. So that's why G to the power 4 is 1, and even if it's multiple 4, so G to the power 8 means 2 to the power 4, right? multiple of 4 also 1. Okay, so that's why I'm saying here in general, if you have j, k plus 4n. 4n is multiple of 4, so this one should be 1. So g to the power k plus g to the power k times g to the power of 4n. 4n, this one is 1. Okay, so that's why it should equal to g to the power k. Okay. So you know here in the complex plane, we have here the x-axis is the real number, y-axis is the imaginary number, as you see here. So, for example, if I have a number here, if I have a point like point A here, okay? So this point A in the real number has A, for the imaginary number it is B for the imaginary number. So if I want to write this number, I have to write it this way, A plus JB. So if you see complex number, we have one part that is real and one part imaginary part. Okay, the imaginary part, we have to put J here. Okay, and this is if you put it in this form, we call it rectangular form. Okay, so if I give you this form here, can you draw it here? Very easy, because whatever you have here in the real number, you have to put it here on the x-axis. Whatever you have here in the imaginary part here, you have to put it here, and by this way you can make point A. Is that okay? Any questions? Okay. Number 2. So here we have another form. So this is one form of complex numbers. It's a real number plus imaginary part here. If the complex number in this format, we call it this is the rectangular form. There is another form we have here, we call it polar form. The polar form. Okay. There is another one we call it polar form, but actually I'm going to focus on these two, rectangular and polar, because all the time we can use these two. Okay. So in the polar form, if you have a point that is one A, okay, I can represent this point A using the length of this line, which I call it the magnitude of A, which is actually the length of this one, okay, and the angle. Okay, so there is another way to represent a point. So I can represent the point using A and B. That's the rectangular form. I can represent the point using the length of this one, which is we call it magnitude of A, and angle, we call it theta. Okay, so we can write it this way. If you know the magnitude and you know theta, okay, so you already have the point. Okay? So conclusion. Complex numbers, we are going to use two forms for the complex number. Number 1, this form here, rectangular form. The second one is polar form, this one here. It's very important to know how can you convert between them. Sometimes you have a rectangular form and you want to convert to polar. Sometimes you have polar and you want to convert it to rectangular. Why? Why I don't just use one of them all the time? Simply because, as you will see shortly, for the rectangular form, it's easy. If you want to do addition or subtraction, it's easier to do it using rectangular form. But if you want to do multiplication or division, it's going to be easier to do it in polar form. Got what I'm saying? So maybe you have two numbers, and these two numbers are in polar form, and I want to do addition. So I need to convert each one of them to rectangular and do addition. And then after you do the addition, you will return it back to polar. You got what I'm saying? You will see right now. But anyway, you should be able to know how can you convert. So again, what I'm saying, for complex number, I will focus only on these two formats here. Okay. We have also E here, but here is the same thing, but we can just use this two. But here also amplitude, but instead of this angle is E to the power J is theta, the angle Z. So these two are very close to each other. Okay. So let's start with the. If you have this rectangular form, how can you convert it to polar form? I need to find the magnitude and I need to find the angle. Okay, very simple. As you see here, the magnitude is actually square root of A squared plus B squared. A squared, which is actually so if I ask you to calculate the length here, this length is actually A squared plus B squared. Okay? A square root. So here, given given rectangular form, in order to get the magnitude, this magnitude, all what you have to do is square root of a squared plus b squared. That's it. That's why it's always positive. Always has to be a positive value. Okay. What about the angle? The angle is actually the inverse of tan b divided by a. So you have to divide b by a, and you need to calculate the inverse of tan. Okay. Again, you can tell from here because tan theta, what is tan theta? It's the opposite divided by the adjacent. Is that okay? The opposite is b, adjacent here is a. Okay, so if you have b divided by a, give it to you, b divided by a, I can get the inverse of 10 to calculate theta. And when it comes to the inverse of 10, that's a trick. When you calculate the inverse of 10, and we'll talk about it. Okay. So again, conclusion, if you have a rectangular form, in order to convert it to polar, all what you have to do is, number one, this is the magnitude of a, square root of a squared plus b squared. Okay. Number two, the angle is actually the inverse of 10 of b divided by a. B divided by a. Is that okay? Now, how can you do the opposite? If you have a number in polar form and I want to get it in rectangular form, how can you do the opposite? The way you can do the opposite, so as you see here, A is actually the magnitude times cosine theta. B is actually the magnitude times sine theta. That's it. So again, multiply this one by cosine to get A. Multiply this one by sine theta to get B. That's it. Very simple. Any questions? For sure, if you have a calculator, and actually most of the calculator can do this operation using complex number easily, I guess. Okay, so you need to find you need to find out how can you do it, because again the difficulty, I will repeat it for the third time, the difficulty in this chapter is not in the circuit stuff itself, but it is only in the computation, because there is no new. I'm not going to teach you new theorem here. I will use what we did before, but the difficulty, everything will be in complex domain. So if you have a calculator that can do this calculation easily, you see this chapter should be just repeat to what we did before. For 10, you know, this is the function of inverse of 10. This function is actually the period here is pi. So if you see here, this is the period from here to here. Okay, and then it's repeated again. So even from here to here, it is pi, not 2 pi. You know, cosine of sine. What is the period for sine or cosine? It's 2 pi, right? So if you have here, this is sine. So from here to here, you can. It is actually, this is that's what we call period T, okay? And you know that frequency is 1 over the period T. The smallest unit that's repeated, which is actually this unit here, because this unit is just repeated. So the time here you put a period, F is 1 over T. You know, in sine, this T is actually 2 pi. Okay? So from here, from this part from here to here is pi, and then another pi here. Okay? So actually, this part here is pi over 4, which is 90, another 90, another 90, another 90. Okay, total we have 360 or 200. Same thing for cosine, because again, cosine is similar to sine, but it's shifted. Okay, so cosine is not something new. It's just simply it's similar to this one, but it's going to be shifted. Okay. But for the inverse of 10, the period is pi, not 2 pi. Okay. So the trick, I told you there is a trick here. The trick is, and you have to be careful here. So the trick is, because we have here, this is quarter 1, this is quarter 2, quarter 3, and this is quarter 4. And this is here A and B. Here A is positive, B is positive, A is negative, B is positive, but here this one, B is negative. So what I want to say is, and this is the tricky part, for example, if A is equal to 2, B is equal to 2, for example, or 3, any numbers, doesn't matter. For A equal to negative 2, B is equal to negative 3. Okay? The problem now, if for both of those, this one here has to be in the first quarter, and this one has to be in the third quarter. Okay? If you calculate the 10, if you inverse of 10, if you get the inverse of 10, 2 over 3 is 16, like negative 2 divided by negative 3, because this negative is going to go with this negative. You get what I'm saying? So if you just calculate 10, inverse of 10, almost it's going to give it to you in this quarter, first quarter, even if it's in the third quarter. You get what I'm saying? Because if it's negative divided by negative, it's going to become positive. So there is a trick. That's why to address this issue here, to make sure you get correct angle, and again, my sincere advice to you, don't just, especially for this part, don't just read the examples by your eyes. You need to do the calculation by yourself. Okay? Just to make sure you can do calculation over or using complex data. So that's why, just to solve a problem like this one, okay? Here, we in the textbook they give us this. This is the way you should calculate it. So again, guys, let me make it very clear, guys. So here, what I'm saying is that if A is 2, B is 3. Okay. So here, if A is negative 2, B is negative 3. If you go to your calculator, okay, and then you divide 2 divided by 3. B divided by A. So here, 3 divided by 2, or negative 3 divided by negative 2, the calculator will give you the same angle, okay, which is actually in quarter, in the first quarter, but it's not true, because this one should be in the first quarter, this should be in the third quarter, okay? So that's why to solve this issue, you need, it's a textbook, they are telling us you have to do this way, okay? Number one, look at A. If A is positive, so regardless what is B, just use this one. So you can use the calculator to calculate this one. Again, if A is positive, regardless what, if B can be positive or negative, doesn't matter. If A is positive, just use the calculator to calculate this one, you are okay. However, if A is negative, so multiply by negative to make it positive, okay? B can be positive or negative, and then you have to subtract this one from 1 each. You get what I'm saying? It's like a correction. So you understand what I'm saying? So now what I'm saying is that this is how you should calculate it. If A is positive, okay, just put A here. B can be positive or negative, it doesn't matter. Just use your calculator to calculate this one. Okay? But if A is negative, multiply by negative here to make it positive, and then B can positive or negative, it doesn't matter. It's similar to what you have. And then, but here you have to subtract this part from 1 each. Again, this is because of the problem I explained here. Okay? So that if it's the first quarter or the third quarter, something like that. Because if you see here, this is the main point. For example, number 4. This 4 can be 4, for example, can be resulted from positive number divided by positive number, or it can be resulted from negative number divided by negative number. If the positive to positive, it has to be here. It has to be. But negative to negative, it has to be here. Anyway, so I don't want to overcomplicate it. I'm trying to justify why you have to use this formula here. That's it. But to make it simple and easy, what you have to do is look at A. If A is positive, just B divided by A. It doesn't matter B is negative, just use this one with your calculator, we are okay. But if A is negative, multiplied by negative, make it positive here. I multiply by negative to make it positive. Okay? And then put B, whatever B, positive or negative, and then after you calculate this one, you need to subtract 180 to get correct angles. Okay? So we have some special cases here. You should be familiar with these special cases. For example, if you have number 1, a real number, here we have a real number, I don't have an imaginary number. Okay? So this one here, 1 is like 1 plus 0j. 1 plus 0j. Okay? So in this case, it should be 1 with angle 0. Okay, so if you have an imaginary number like j, but you don't have a real number, okay? So this one should be 1 angle 90. Okay? Same thing here for negative j, for 1. So this sum, you should be able to know how can you calculate the term. Okay? The last thing here, the other thing I want to teach here, how I can say 2 points are equal or not. If I give you 2 points, how can you say if they are equal or not? It's very simple. For example, here I have A plus JB. I have X plus J1. Okay, any 2 points. Same thing, I have here A with angle theta. Here, for example, I call it B and theta 1. How I can say this point is equal to this point, okay? Or this point is equal to this point. How I can know? Very simple. Here, these 2 points are equal only if the real part equal to the real part and imaginary part equal to the imaginary part. Very simple. You got what I'm saying? So if they are equal, that means the real should equal to the real, imaginary should equal to the imaginary, if they are equal. Okay. Same thing here in polar form, the magnitude, if they are equal, the magnitude should equal to the magnitude and angle should equal to the angle. Okay, that's how I can say they are equal. Okay, any questions? Okay. The other thing I want to teach you is how can you do addition and how can you do subtraction and subtraction. For example, if you have, let's have some number, 3 plus J2, for example. Okay, I want to add this one to 5 plus J3, something like that. So I have two numbers, two complex numbers. I want to add them together. Okay, so if you want to add them together, the way you have to do it is, number one, you add real to real. You have to real part to real part. So now it becomes A plus. You need to add complex to complex. So now G5. That's it. That's why I'm saying if it is in rectangular form, addition is easy. Just add the real part to the real part, the imaginary part to the imaginary part. Okay? Same thing if you have here subtraction. So for example, if I do subtraction like 3 plus G2, I want to subtract 5 plus G3, for example. Okay, so that means I will subtract these two first to here. Again, real from real, and but here, if one of the things here, if it is subtracted, so you see this negative here, if you have negative 5 plus G3, so this negative is going to be here, so it should be negative 5, negative G3. Okay, so this negative has to be for both of them. So now this one should be 3 negative 5. This is the real part. You subtract real from real and imaginary from imaginary. Okay, and then here you have J. And here you have 2 minus 3, okay, which is negative 2, okay, minus J. Okay, guys. So now I explain if you have 2 numbers, how can I can tell if the 2 numbers equal or not? That's number 1. Number 2, I explain if you have 2 numbers in rectangular form, how can you add? How can you subtract them? Is that okay? If you have also. For example, if you have a number like this one, 2 plus G3, for example, and I multiply it by 5, by number 5. Okay? So here's the way you have to do distribution here. So this one should be 5 times 2 plus J 3 times 5. Is that okay? So if you have a constant number here, so you have to do distribution here. So that means this one should be 10 plus J15. Okay? Now, how can you do multiplication and how can you do a division? Okay, as I told you before, multiplication and division, it's easier to do it in the polar form than this one. For example, I have here number 3 with angle 30. I want to multiply this one by, for example, number 2 with angle 20, something like that. Okay, how can you do this multiplication? It's much easier here to do it than the rectangular form. All what you have to do is you have to multiply the magnitude by the magnitude. So now it becomes 6. For the angle, you have to add the 2 angles. So it should be 30 plus 20. So the result should be 6 with angle 50. You have to add the 2 angles. Okay, guys? So you have to multiply the magnitude by the magnitude, and then you have to add angle to angle. Okay, What about division? If it is division, for example, you have here 10 with angle 30 divided by 5 with angle 2, for example. Okay, if you want to do division, what you have to do here is you need to divide the magnitude by the magnitude, so it's going to be 10 divided by 5, and for the angle, should be 30 minus 2. So here it has to be minus 2, minus 2. Okay, so it should be here 10 divided by 5 is actually 2 with angle of 28. Again, if you want to do addition with subtraction, it's easier to do it in the rectangular form. If you want to do division or multiplication, it's easier to do it in polar form. Okay? But that doesn't mean you cannot, for example, here, if I want to multiply these two numbers, for example, 2 plus J3, I want to multiply, for example, by 1 plus 2J. If I want to multiply these two numbers, okay? In my opinion, the easier way to do it, unless your calculator can do this multiplication. If your calculator can do this multiplication, okay, it's easy, okay? So what you can do here, you can convert this one to a polar, you can convert this one to a polar, and then you can do some multiplication because it's easier to do it in polar, okay? But still, if you want to do it in rectangular form, still yes, you can do it. But maybe in polar it's easier, but still you can do it. The way you have to do it, you have to do it using distribution. Okay, so here 2 times 1 is 2 plus 2 times 2 is 4J plus J3 plus 2J times J3. Okay, 2J times J3, this one here is negative 6. Makes sense? Still you can do it if you want to do it in rectangular form, still you can do it. But maybe it's easier to do it in polar. Okay, and then after that, any real numbers you can add together, any imaginary number you can add together. So you can see here, we have here 2 and we have negative 6. So the result should be negative 4. And we have here 4J and we have or 4J or J4, sometimes I switch between them, it's the same thing. So if I say J4 or 4J, it's the same thing, okay? So here, J4 and J6, okay? So here, these two are imaginary ones. So here I can say plus 7G. So any imaginary, you can add it to imaginary, any real, you can add it to real. Okay, guys, any questions? So I have here, let's see the examples. I have several examples here just to make sure. Yeah. So for example, here, let's look at the examples I have here. Yeah, so here show this complex in the graph here, and also you need to convert between them. Okay, let's see. So for example, A1 equal negative 1. This can be a complex number, by the way. So you may think this is only a real number. No, this also can be a complex number with G0. So number one, if I want to draw it here, so this one A1 should be here. Okay. If it is negative G2, so actually here, this is E2. So here, so negative E2 is here, as you see here. It only has the imaginary part, it doesn't have a real part. Okay. Let's look at the next one here. Negative 2 plus G1 or G. Okay, so negative 2, I'm gonna come here negative 2, and then I'm gonna come here only 1, and then this will give you A3. So you can see here A3, negative. The real part is negative 2, the imaginary part is 1. Okay, the last one here, or this one here, 2 with angle 30. So it is 2, so here, if you look at the length here of this line is 2, and with angle 30. Okay, this is how you draw it if you need to draw it. Now I want to convert any rectangular to polar, any polar to rectangular. So let's start with this one here. We have here negative 1. Okay, so here negative 1 actually it means you have 0 here. G is 0. Okay, so as I told you, if you want to convert this one to polar, number one, I need to find the magnitude. And the magnitude is actually square root of the real part square plus the imaginary part square. So actually here is this one should be positive one because this one, this is the length, so it always has to be positive. Okay, even if this one negative, this one has to be always positive. So you can do this way. Now for 10 inverse of 10, so now it is 0 divided by -1. If you go to the calculator and you ask for 10 0, it's not gonna give you 180, by the way. I think it will give you 0. That's why this is the part I told you it's tricky. Okay, you should not, if you use the calculator, it will give you 0. That's why you have to use this formula here. Okay, so if this one is 0, but this one is -1, I'm gonna make it +1. Okay, and now this 10 is 10 0. Inverse 10 of 0 is actually 0. Okay, so here and the result will be 180. Okay. So now once you have the amplitude, once you have the magnitude and you have the angle, you can write it in the polar form this way. You can also write it in polar form this way. Let's see another example here. -G2. Okay. So this one here, the real part is 0. Real part is 0. Imaginary part is -2, as you see here. Number one, how can you get the amplitude? Sorry, the magnitude, the square root of the real part square plus the imaginary part square equal to 2. Okay. Same thing here. How can you get the angle here? Okay. This is the inverse of infinity, negative infinity. This one of the special things you should know somehow. I don't know the calculator. How can you? I'm not sure. You can check your calculator. How can you calculate the inverse 10 of negative infinity? Maybe some calculators have negative infinity, or maybe this is one of the special cases you just need to learn. Okay, so this one should be -90. So the angle here should be 2 and -9. Number 3 here is 3. We have -2 plus G1. I want to convert it to the polar form, similar to what we did. You need to square this one, the real part, imaginary part, you need to square this here, and then you take the square root. This gives you the magnitude. Again here, this should be 10 of -1. Look here, B is positive, okay, but the imaginary part is negative. So that means this one should be in the second quarter. So try to think about it. So if you get a number that's less than 90 in the first quarter, something is wrong. But I'm saying, because this is B divided by A. The imaginary part is positive, but the real part is negative. Okay, so this should be the second quarter. Okay? Anyway, so you can apply the formula I put before. You will get this number. Again, the difficulty of this part, you need to be familiar with the calculation using complex. It's your responsibility to do that. You have a calculator. You need to repeat all these calculations. Okay. The last one here is already in polar form. I wanna make it in rectangular form, as we see here. Okay, as you know, in the rectangular form, A and B, A is actually the magnitude times cosine, magnitude times sine. Cosine or sine is just direct, so we don't need to do anything, just use the calculator for cosine or sine. Okay, so here should be 2, the magnitude is 2, and the angle is 30. So here 2 cosine 30, 2 sine 30. That's why you can get this 2 here and just put this here. Okay? Any questions? So multiply the magnitude by cosine to get A. Multiply the magnitude by the sine to get B. Always this magnitude has to be put in example. If you calculate it and you find negative, so something is wrong. Always the magnitude has to be positive. Okay? Any questions? Okay. And also in complex number, there is something we call it conjugate. The conjugate of a complex number. Okay. How can you calculate the conjugate and what it means? Because we will use it. Okay. So if you have a number A, for example, if I have a number A this way, it is 3 plus J5. Here, I can calculate the conjugate of A. we put asterisk this way, A asterisk. So A asterisk means this is the conjugate of A. This one should equal to 3 negative J5. So all what you have to do, very simple. All what you have to do, you should not change the real part. You just, all what you have to do here, just change the sign. It's the sign of the imaginary part. So the imaginary part is negative, make it positive, positive, make it negative. That's it. Okay? So this is what we call the conjugate. Conjugate of a complex number. So for example, if it is A equal to minus G3, the conjugate of A should equal to 2 plus G3. Okay? Just to change the sign of the complex part. The second thing here, what if this number is polar? So for example, you have here A is equal 3 with angle 20. Okay? Or A 3 with angle negative 20. Okay? Angle can be positive or negative, but what you have in magnitude here always positive. Let me have another number, for example. Okay. So if you want to calculate the conjugate of this one, all what you have to do, just multiply the angle by negative, and don't change the magnitude. So this one should be A is equal to 3 with angle negative 20. Here, this one A should equal 2 with angle positive 20. Very easy, right? So to calculate the conjugate in case of polar form, the angle, just to change the sign of the angle. That's it. Okay. We will need to use the conjugate here. So this is the conjugate. So what this conjugate means? Okay, it means, or for example, if you have here, if you have A, for example, equal A plus JB. If I calculate the conjugate of this one, A asterisk, it should equal A minus JB. Okay. If you multiply A times A conjugate, so if you multiply a number by the conjugate, what you are going to get is square plus B square. So if I multiply a number by its conjugate, so this number, so the result, it doesn't have any imaginary part, only real part. Okay. And this is actually, by the way, you remember the square root of A square plus B square equals the magnitude. The magnitude of A. So that means this should equal the magnitude square. So if I multiply a number by the conjugate, what you are going to get, the magnitude square, or A square plus B square, it doesn't have a conjugate number. Okay, guys? How can we use some, at least for now, because we are going to use it next chapter, but how can we use something like that, at least for now? Okay, if I wanna, as you know, for example, you have 2 plus J2, for example, any numbers, okay? 3 plus J. If you have to, if I want to divide these two numbers this way, okay? Again, the easiest way, you need to convert this one to, for example, A and then angle theta 1. And then you need to convert this one to B angle theta 2, whatever theta 1 and theta 2. And then after that should equal A divided by B with angle theta 1 minus theta 2. Yeah, this is the easy way to do it. Just that you need to convert every number to the polar form. Okay? But you can do it in the rectangular form as well, but it's gonna be more difficult, but still you can do it. How can you do it if you remember? Should be, for example, 2 plus J2 divided by 3 plus J. What is the problem here? The problem I have imaginary part here. Okay, so I need this imaginary part, I need to get rid of it. To get rid of this imaginary part, simply I'm gonna multiply by conjugate. So here this one should be 3 minus J divided by 3 minus J. So should equal to 2 plus J2 times 3 minus J divided by, I told you when I multiply by conjugate, the first one is square plus the second one is square. Okay. So now, so here it should be 2 plus J2, 3 minus J divided by 10. Sorry, whatever the number here, okay, 82. And then after that you can do here, you can do the multiplication here as I explained to you before. For sure, this is a more difficult way, but just you may need it. But I think in my opinion, the easier way is just to convert this one to rectangular, and then once you get it to rectangular, sorry, in polar, you can actually return it to rectangular again if you want. Okay? But here, so it should be 1/82 times. Then you need to do the multiplication as I explained to you before, like 6 minus 2j. Okay, 2j. So here I'm multiplying. Let me use a different color. Yeah, I'm multiplying 2 here and 2 here. G here and G here. Okay, so it should be plus 6j plus j by times j is negative, and we already have negative plus 2. And then you can add, so it's 1/82 multiplied by, you add real to real, so it should be 8 plus 4j. And then you can divide this one by both terms, so it should be 8 divided by 82 plus 4 divided by 82j. Okay, guys? Yes, sure, to explain that. Plus 2. Plus 2, okay, because here I'm doing distribution, so here I multiply G2 by negative G. So G2 times negative G. Okay, G times G is negative 1. Okay, and we already have negative 1, it becomes positive 1, within 2. Because G times G is negative 1. Yeah, sure. Yes, because, okay, let's, the beginning is here, okay? In order to get this one, I need to get rid of the imaginary part here. The only way to get rid of the imaginary part is actually multiplied by the conjugate up and down. Okay? And when you multiply a number by its conjugate, the result is the real part squared plus the imaginary part squared. Okay, that's what I think it's a better one. You got what I'm saying? And that's what I did. So what I did here, when I multiply, if you have, let me come here. So if you have here A equal, or if you want to multiply two numbers, A plus BJ, I want to multiply by its conjugate, A minus BJ, the conjugate. If you want to multiply a number by its conjugate, the result is A squared plus B squared. Whatever the number is, maybe I made a mistake. Whatever is it's my fault. Okay. Whatever the number, 3 times 3, you are right. It's 9. Okay, plus 1, so it should be 10. So it's not 9 squared, it's 3 squared. Okay, that's okay. Yes. Okay, guys. Any questions? So again, you have examples here. Again, you need to focus or you need to practice. How can you do a calculation using complex number? Because that's what we are going to do this chapter and also the next 2 chapters as well. So from now until the end of the we are going to work only with complex numbers. Okay? So it's not going to only affect this chapter, but also the coming chapters. Okay? So here I give you. So what is the meaning of a conjugate? A conjugate actually, as I'm reading here, it's a mirror image of A with respect to the real axis. So as you see here, this is A and this is the conjugate of A. So it's actually going to be like a mirror, in a mirror of A, and using in the real number with the real axis. Okay. So here, yeah, here this is just a practice. How can you calculate the conjugate? Okay. So let's see in this example here. So you have here, you have real part plus 0j. Okay. So that means if the conjugate here is positive, j has to be negative j. So that means it's negative 1. That means the conjugate of negative 1 is negative 1. They have the same. So, okay. It's just a special case because we don't have here a imaginary part. So let's look at the second one here. It's a negative G2. Okay. Again, this one means we have the real part is 0 and G2. Okay. So all what you have to do very simple to calculate the conjugate, just to change the sign. The of negative should be positive this way. So that means it should be positive G2. Okay. Same thing here. If this one is negative 2 plus J 1, all what you have to do just to change the sign from positive to negative. That's it. Okay. Same thing here is in a polar form. You only need to change the angle. Don't change number is only you need to change the angle. Is that okay? One thing may be confusing some students. If you have for example, a number something like 3 plus G2, I want to multiply it by 5. So this 5 has to multiply here and here as I told you. So it should be 5 times 3 plus J2 times 5, which is equal to 15 plus G10. Okay. But if it is an angle, if it is in a polar form, like for example 10 with angle, for example 30, for example. So this number will only be multiplied by the 10, not 30. So this should be 5 times 10 with angle 30. We don't multiply it by the angle. Okay. Any question? This is if you want to multiply, a constant number by imaginary number, this way is two different, these two forms. Okay. Yeah, that's what I did about. That's what I said about addition, multiplication. Yeah. So here, just you have some examples here. How can you do subtraction? So for example, here I want to subtract. You have A1 in this format here. I have A2 in polar, and I want to subtract A2 from A1. Okay. The easier way, I can just convert. I can convert this one A2 to rectangular, and then I do the subtraction. To convert this one here, as you know, 2 cosine 30 plus J2 sine 30. Okay. So now A2 should be equal to this number here in rectangular form. And now I can do subtraction. So I subtract this number to this number. So now I am going to use the equivalent form of this number in rectangular. Okay? And then when you do subtraction, it should be 1. This minus is going to be distributed here. Okay? It should be this one minus, this one also minus. Okay? So it should be 1 minus this one here. Real, okay? Real and real. This also imaginary from imaginary. So here G2 minus 1. Okay. Any questions? That's what I said here about how can you multiply two numbers in polar format. Just multiply magnitude by magnitude, and you add the angles. When you division, you divide, okay, magnitude by magnitude, and then you subtract. Okay, subtract is angles. That's also what I told you. If you want to do multiplication in rectangular form, still you can do it, but maybe more difficult than the polar form. So this is you have to do distribution, as I told you. A1 has to multiply here, A1 has to multiply here, this one has to multiply here, this one has to multiply here, and then after that you can add real numbers together and imagine numbers together. You can do it if you want. Yeah, that's what I said about if you multiply a number by its conjugate. If I multiply a number by its conjugate, I will get magnitude squared, or A squared plus B squared. It's the same thing, right? Yeah, so if I multiply a number by its conjugate, I'm gonna get magnitude squared or A squared plus B squared. Okay, so that's what I said about division. If you want to divide rectangular by rectangular, for sure, the easiest way you can convert both of them to polar and then do the division. The other way here, in order to get rid of this imaginary here, you need to multiply by the conjugate here, up and down. Okay, and then after that, as you see here, just do multiplication, and this one here, this part here has to be divided by all of them. And again, you need to add real to real and imaginary to imaginary. Any questions? Yeah, I give you here one example. How can you do multiplication? I don't want to spend more time this one. I want to start how can you convert a circuit in real time to complex? Okay, any questions? Okay. So now what I did so far, guys, I made very quick revision, but still you are responsible on because again, not only this chapter and next two chapters as well, we can use complex numbers also. Okay. So as I told you guys, here, if you have a circuit, whatever the circuit is, but again, all the circuits we have should be cosine omega t or sinusoid. Okay, it's not DC anymore. Okay, and then what's going to happen is you have here some elements. As I told you, we need to convert this circuit to another circuit using complex numbers. Okay, in order to explain this one, I need to explain how, if you have a source, how can you convert this source from time domain to complex domain? If you have a resistance, how can you convert the resistance from the time domain to complex domain? Same thing for the capacitor, same thing for the inductor. Okay, so that's exactly what we'll do. So it's going to be exactly the same circuit, but the source is represented using a complex number. Resistance, everything here is should be using complex number. So I'm going to teach how can we do every element individually. Okay? So I will start with the source here. Again, this source can be voltage or it can be current. Okay, for example, if I start with voltage, for example, you have Vm cosine omega t plus theta this way. So again, if you know, if I wanna do this one here, let's start with, for example, if I wanna do Vm cosine omega t. Okay, this is a reference one without any phase angle. Okay, so this one, as you know, has to be, this is the cosine. Okay, this is V maximum, Vm is here, Vm is here. Okay, if you take any 2 points, for example, this point and this point, sometimes here is the T, the period T, or any, for example, I can take this point and the corresponding exactly 1 point. So anyway, if you take any point and the corresponding point, you will see the time between these 2 points is we call it the period. Okay, the period, which is T. Okay? And 1 over T should give you the frequency. And omega should equal 2 by f. This is omega t. Okay? So let me ask you a question. This is the reference one. This is that line. Vm cosine omega t. Okay. What is the impact if I add theta here? What is the impact? If you have any function and then you add something to the x-axis, actually what you do, you shift. You know what I'm saying? So the adding of theta here, this signal will be shifted either to the left or to the right by the amount of theta. Okay? So if theta is positive, it's going to be shifted this way, okay? And if theta is negative, it's going to be shifted this way. Any function, if you change x, for example, x plus 5 or x minus 5, you actually shift the function over x-axis. You know what I'm saying? So this is the impact. So this should be, we call it reference. This is with theta equal to 0. Okay? This is actually cosine omega t. But when you add theta, so this one will be shifted. Okay? And that's what I'm showing here in this figure. So what I'm showing here in this figure, if you have a voltage source, this source is actually Vm or cosine omega t plus theta. Okay, theta can be 0. So this is the reference. The reference here, theta is equal to 0. Reference 1. Okay. So this theta here can tell me how much you shifted. Okay. You can shift it to left or to the right. If it is positive to the left, negative to the right. Is that okay? So here we have here T is the value, F is the frequency, which is 1 over T, omega 2 by F. Vm is the magnitude. Cosine itself is the magnitude. The cosine itself, the maximum value positive or negative 1 maximum. Okay, same thing for sine. So sine itself, the maximum is positive 1, negative, minimum is negative 1, right? But when you multiply by Vm, so now the maximum becomes Vm, minimum negative Vm. Okay, and theta is, we call it the phase angle. phase angle. Very important thing, phase angle. Okay, so this phase angle can tell you how to shift. Okay, shift it. Comparing to the original one, this one doesn't have a shift. This is the original one, omega t. You can shift it left or right. So here, if I shift it theta, so as you see here, it's going to be shifted by theta this way or that way. Same thing, although this signal for voltage, Vm cosine omega t plus theta, we can do the same thing for current. If you have a current here, Im cosine omega t plus theta. That makes sense? Or theta I, whatever the name, doesn't matter. Theta I, and this one sometimes we call it theta V. So we have theta for V, theta for I. And as you will see, sometimes theta here is the same like theta here. Okay? Sometimes they are different. It depends on the element, as I will explain. Okay? But anyway, so here I will explain this one. But anyway, so again, I can represent the voltage using cosine this way or sine this way. The other thing here, because I will teach, what I'm going to teach is, if you have a source, either the source is a voltage source or current source, okay, VF cosine omega t plus theta, okay. How, this is in time domain. How can you convert it to the complex domain? Because that's what I said. What I'm doing right now is, I will talk about source. How can you convert to source? Then I will talk about resistance. How can you convert inductor? How can you convert capacitance? How can you convert? And once you convert the circuit to the complex domain, we will use everything we used before, Norton, definite everything. Okay. So how can we convert this one from time domain to a complex domain? Okay. I'm going to tell you how we do it. Okay. So here, if you have a phasor, and this phasor is actually Vm with angle omega t plus theta. Okay, this is a complex. So you know, if you have a phasor this way, or if I have a phasor this way, here this is point A, and this one is Vm. Okay, and the angle here is actually omega t plus theta. Is that okay? So I can say, I can convert this one to this phasor this way in the complex domain, and I use it. But with the second, but there is something here, because if you look at what is the x, this part here, the projection over x-axis, the real part. What is the real part of this one? Okay, the real part of this one is actually Vm cosine omega t plus theta, which is this one. So the way I can do it here, guys, what I'm saying is that if you have Vm cosine omega t plus theta, I can represent it using Vm with angle omega t plus theta. Use it here in the complex domain. Okay, and then if you want to go back, I will do the same thing, but I will only take the real part. Okay, why? Because actually the relation between these two, the real part of this one should give you this one here. So again, the way when you convert it, I can convert it this way, okay, and then I can use it in the calculation. But after, when you go back, for example, after I used it, I find the current or the voltage, for example, voltage over a resistor, for example, equal 3 with angle 70. Okay, so when I go back from here to here, okay, so what I'm going to do here, I'm going to take only the, so this one should be 3 cosine 70. This one should be, I'm sorry, so for example, omega t plus 70, something like that. So this should be here, omega t plus 30. So I'm going to take only the real part. Okay, so what I'm saying here, guys, is that if you have a source like this one, I'm going to represent it as a phasor this way, then take it in the calculation. But when you do the opposite, when you want to convert it from the complex domain, go back to the time domain. Okay, so here after you do the calculation, and we get something like this is the voltage across the resistance. This is the complex number. when you bring it back here, you have to take the real number, only the real number, because this one was the real number of this one. Okay, so when you go back, you can take only the real number. Okay, but wait a second. You understand what I'm saying here? So what I'm saying is that if you have a voltage source like this one, I can represent using a complex number this one. Okay. But this one is the real of this one. Okay, but I can use this one in the calculation, and then after I fix any number, I will get the real part of this number, okay, to convert it to the time domain. Okay. But I can simplify it more. How can you simplify it more? I will tell you. Look here, guys. As I told you, if the input is sinusoidal, like this one, because the circuits we are using are linear circuits. So if you calculate the voltage or the current everywhere, frequency is the same, omega is the same. You got what I'm saying? Linear circuits don't change omega. What may change the amplitude or the angle, theta. Theta can change, angle can change, but still omega, right? So why I can simplify the calculation? Why I have to carry omega if I already know, okay? Omega will be same. So in order to simplify it more, I'm gonna cancel omega from it. So I'm gonna say if you have Vm cosine omega t plus theta, I'm gonna, when I convert it, I'm gonna use Vm here, Vm with angle C. I'm gonna only take theta. Okay? However, when you do the opposite, when you come back from here to here, I need to compensate, I have to add this theta here, omega theta. So let me say it again. What I'm saying is that the correct way that should be omega t plus theta t. Okay? But because I know any result I will get, it should have omega t. Why I need to complicate calculations? And omega t, I know it will be omega t. So I can remove omega t, and then I can represent this one only using Vm and theta. But when I go back, after I get a voltage current, anything, when you go back, you have to do two things. Number one, you have to take the real part of the result. Number two, you have to add omega t. Because I removed it from the calculation in the beginning, so I have to add it. Is that okay, guys? Let me tell you the conclusion. The conclusion is if you have a source this way, for example, 5 cosine omega t plus 20. Okay, so when I convert it to the complex domain, it will be a source this way, 5 with angle 20. Okay, I'm not going to use omega, for example, I'm going to say 100t, which is omega t, just use numbers, 100t. Okay, so here, I'm going to only, when I convert this one here, I'm going to use the magnitude, the same magnitude, this one here, and the angle. I'm not going to use omega t. However, okay, so here you have some resistance or whatever. When I calculated the voltage here, I found the voltage here, for example, 2 with angle 10. Okay? This is in complex domain. So if I want to convert the voltage here across this resistor, if this voltage across this, if I want to convert it to the time domain again, it has to be 2 cosine omega t, which is 100t in this case, because I removed it from here to make the calculation easy, plus 10. Okay, guys, is that easy? So if you have any source, cosine omega t plus angle, I will represent it like only magnitude and angle. Okay? When you go back from the complex number to the real number, you need to add omega t because I removed it from the calculation just to make the calculation easy. I don't need to say omega t, because it will be everywhere omega t. Because I already know in linear circuits, if the frequency of the source will be the same everywhere, every voltage, every current has the same frequency. Okay? Any question here? Okay, good. So now the question is, so here I'm expecting that any sources, the standard to format for sources, they have to be this way. It should be Vm cosine omega t plus t. This is how If it is this way, you can proceed this way. So it has to be this way, okay? Theta can be 0, can be positive, negative, whatever it is, it doesn't matter. It can be 0. Theta can be 0. It doesn't matter, okay? But this is the standard format I have to use to map it to complex numbers and then to go back this way, okay? Maybe I'm not gonna give it to you in cosine. I can give it to you in sine. So you need to convert it to cosine because it has to be cosine, okay? So for example, I can give you Vm sine omega t plus theta, something like that. Okay? So you need to convert from sine to cosine because the standard we need to use cosine. Okay? How can you convert the sine to cosine? Okay, look here, guys. This is sine and this is cosine. This is cosine. Okay. So what happens here? If I shift, so here I can say this one is Vm cosine omega t plus theta minus 90. So here what happens here, if this is the cosine, if I can shift the cosine this way 90, because this is 90, it becomes a sine. Is that right? So if you look at the cosine here, if I shift it 90 this way, it becomes a sine. This is a relation between sine and cosine. So again, final conclusion is I'm expecting you have to give me Vm cosine omega t plus theta. This can be solved, can be solved this way. If I give you to this way, all what you have to do here has to be Vm with angle theta. Take it in the calculation. After you take in the calculation, whatever you will get, something like, for example, 3 with angle 20. When you come back to the time domain, it has to be 3, okay? Cosine omega t plus 20. Okay? Same thing, here this is for the volt. Same thing can be for the current. Can be Im cosine omega t plus theta. It's exactly the same thing. When I convert it to the complex domain, it should be Im with angle theta. Okay? After you do the calculation, it has to be whatever the value you have, like 5, also cosine omega t plus the angle you will get. Okay? One more thing, if I give you the voltage source or the current source, it is not in cosine. If I give it you in sine, you have to make it in cosine by subtracting 90. Okay? So I think that's what I'm explaining here. So what I'm explaining here, guys, you have Vm sine omega t. I want to convert this one to cosine. So here, just subtract 90. That's it. You shift it. Because sine and cosine are the same, just shift. Okay? If you shift the cosine by 90, it becomes sine. Very simple. Okay? So if I give you something like that, I'm not going to work on this one. It has to be in the standard format, which is cosine. So here I'm going to subtract 90. Same thing, if I give you this way, omega t minus 90. Okay? So here, I can convert it to cosine by subtracting 90. So we have here minus 30 minus 90. It should be minus 128. Okay, guys? Yeah, here, that's what I explained here. B of t, Vm of cosine omega t plus theta should be the real part of the real part of the phasor we have here, which is actually Vm cosine omega t plus theta. And then after that, as I told you, we can remove omega t. There is no need to keep it. Just it's gonna complicate the calculation without, because anything you will get should have omega t anyway. You can delete it. Okay? And that's what happened here. So the final conclusion, the final conclusion is here, guys. This is the final conclusion. If you have Vm of cosine omega t plus theta, when you convert it to a complex domain, it has to be Vm with, I'm going to take the maximum, the magnitude, also the maximum here. Also, I'm going to take theta. Okay? Ignoring this one. Also, when you go back, you have to do the same thing. So look at the arrow here. It's two directions. So when I come back, if I have this one in the complex domain, I have to make it this way. You see what I did? So if you do this way, when you go from time domain to complex domain, also you have to do the opposite. If you get any current, any voltage, anything, when you convert it back, you have to add omega t. Number one, you have to take the real part of this one. Number two, you have to add omega t. Okay? Any questions? Okay, guys, so. Okay, so thirty days it will be, I will teach you for 30 minutes, and then after that, it will be a test for 45 minutes, okay? I told you already what will be in the test. So we have here some grading stuff. If you didn't get anything graded, the TAs here is gonna, if you look at it, you can check these.
It's probably on Tuesday. Thursday, I think.